Through such precision instruments as these, our standards of accuracy are being changed. Science has opened the gateway to new conquests in accuracy of measurement. The yardstick has expanded until hundredths of an inch, thousandths of an inch, even millionths have become measurable quantities. And the power of man's senses has been extended to reach into a new world that he cannot see or hear or feel without the aid of science. A world in which the most familiar objects become strange and unrecognizable because our standards of comparison have grown infinitely small. Chemists and engineers, the scientists of industry, are becoming more and more familiar with the fantastic land beyond the microscope. Through lenses which magnify hundreds and thousands of times, metal experts count and even measure the crystal structures which make up iron and steel. A measuring stick smaller than a pinhead is used, with tiny lines a thousandth of an inch apart. Under the searching lens of the microscope, small blocks of metal in the laboratory tell the secrets of the millions of tons of iron and steel that go into the huge manufacturing plants. And in these plants, microscopic precision controls the form and size and surface of every part. Through the development for factory use of all these precision devices for the measurement of things infinitely small, within limits of tolerance that are almost absolute, we are now able to meet the precision demands of quantity production of fine parts on the basis of standardization and complete interchangeability. Gauges to test the hardness and toughness of metals are miracles of modern precision. A device known as a scleroscope is used to measure the degree of resistance of metal parts such as the camshaft. A small weight in the tube is dropped on the surface being tested. The amount of bounce measures the hardness of the surface. Hard metals are also tested in a large master gauge. The metal is placed on a support and a diamond point is forced into the surface. The distance the point penetrates is measured accurately on a dial to determine the exact degree of hardness. A similar type of master gauge is used for checking the toughness of metals. In this method, a steel ball under great pressure is forced into the surface of the metal. The dent or hollow formed in the test specimen is measured under the microscope. Master instruments check the accuracy of measurements within 1/100 thousandths of an inch. Master gauges check the accuracy of tools and parts used in the factories and on the assembly lines. This precision control of manufacturing operations, for example, gives an exact fit between piston and piston pin. The size of the parts is so accurately controlled that if the piston is chilled for a moment on ice, it will contract. And the pin, when warmed, will expand enough so that the two will no longer fit. Under all ordinary conditions, the two parts will fit perfectly. But if we reverse the operation and warm the piston, it will expand again, and the pin, chilled on ice, will contract and now fits too loosely in the hole. Limits of accuracy in inspection of piston pins are so small that they are almost beyond comparison. Finished pins fit smoothly into the pistons with no difference in size over 1/10 of a thousandth of an inch. Surfaces of moving parts are checked within extremes of measurements that are invisible to the human eye. Sensitive electric meters and delicate feeler points check piston diameters in terms of a single inch divided into 10,000 parts. Cylinders are checked for equal perfection in diameter, roundness, and smoothness. Precision cutting machines shape and round the cylinders. Precision polishing machines polish and grind the walls to smoothness. and precision gauges guide the inspection of the finished work. The pistons move up and down in the cylinders of the automobile engine with just enough room to spare for a film of oil thinner than the walls of a soap bubble. In the careful assembly and fitting together of the parts, many different types of gauges are needed. In the factory, a gauge known as an amplifying indicator is used as a precision check on the fit of the main bearings. A delicate feeler arm which travels over the surface of the bearing is connected so that its slightest movement shows on a dial marked in 10,000ths of an inch. The tools called go and no-go gauges automatically guard the perfection of every part. The utmost precision is carried directly into every step of manufacture. The openings between the two prongs of this gauge have been set according to exact measurements. A valve stem that will not go through the top opening is rejected because it is too large. A valve stem that will go through both openings is also rejected because it is too small. A perfect valve stem will go through the top opening and will not go through the bottom opening, yet the difference is less than the thickness of a hair. Inspection of automobile parts in the factory requires the use of many different sizes and shapes of gauges. Special gauges are used to measure the surfaces of transmission gears. Slight imperfections are magnified so that only perfect gears may find their way into the finished product. The dials detect the smallest variation in the sensitive feeler point as the gears are inspected. Another tool, electrical pickup and amplification, has been perfected and put into use to detect flaws. Does this sound like the rhythmical beat of a jungle drum? Actually, it is the sound of a human heart which science can amplify 1,000,000 times, just as sound can be amplified by measuring instruments in factories to make sure that gears are smooth. Throughout the great manufacturing plants, tools, instruments, gauges work with almost uncanny intelligence, sorting and selecting, checking, passing or rejecting, ever on guard for the slightest imperfection. Accuracy, precision, exactness have been brought to new significance in the microscopic world of scientific measurements, utilizing everything that modern science and research can provide in the way of measurements that are precisely so.